Today we are going to work through some calculations from equations. For question 1, calculate the mass of magnesium chloride produced in the reaction of 4.9 grams of magnesium with excess chlorine. So the first thing to do is have a think about what steps you need to complete these questions. So step 1 is to have a look and decide whether the equation is balanced or not. So if we have a look here, we can see we have 1 magnesium on our reactant side and we have 1 on our product side. And if we look at the chlorines, we have 2 chlorines on our reactant side and we have 2 chlorines on our product side. So this equation is balanced. So we can say step 1 is done. Okay. Your second step is looking at the mole ratio that you have from that equation. However, what I tend to do at this point is get rid of any unnecessary species that we're not going to use. So if we read the question again, calculate the mass of magnesium chloride, so that's what we want to calculate, produced in the reaction of 4.9 grams of magnesium. We've got some information about this species, so that's the other one we're going to look at. Okay, if it says excess chlorine, it means you don't know how much you've got, so it cannot be used in the calculation at this stage. So we can rewrite it, so we can write magnesium. Now this is then step 2, having a look at our mole ratio. Okay, so remember, if we don't have a big number in front of our formula, we say that that's 1. So we've got 1 mole here of magnesium, gives us 1 mole of magnesium chloride. Our third step comes from calculating the number of moles that we actually have. So this is what we would have in an ideal world if we had a perfectly balanced equation. Okay. However, we don't work in an ideal world, so we've got to figure out how many moles we have in reality. So step 3 is calculating the number of moles of magnesium. Number of moles equals the mass divided by the gram formula mass. Our mass is given to us in the question, it's 4.9 grams. And we have to work out the gram formula mass of magnesium. Now if you use your data book, you will see that the gram formula mass of magnesium is 24.5. Substituting that up, 4.9 divided by 24.5 will give you 0.2 mole. And that's step 3 done. Step 4, remember, is going back and working out our new mole ratio. So in an ideal world we would have 1 mole to 1 mole, a 1-to-1 ratio. However, this time we have 0.2 mole of reactants. So what we're going to have is 0.2 times 1 divided by 1, or it's a 1-to-1 ratio, so we can say it's now a 0.2 to 0.2 ratio. And that's step 4 complete. For step 5, we have to calculate what the question's asking us. So this time we're calculating the mass, of magnesium chloride. Mass equals the number of moles times the gram formula mass. Our number of moles we can bring down, it's 0.2. And we need to work out our gram formula mass. Now magnesium chloride, we have 1 magnesium with a relative atomic mass of 24.5, and we have 2 chlorines with a relative atomic mass of 35.5. Add that up and you'll get 95.5. You bring this value up here for our gram formula mass. So our mass is 0.2 moles times 95.5. And the answer that we get there is 19.1 grams. So the mass of magnesium chloride produced in the reaction of 4.9 grams of magnesium with excess chlorine is 19.1 grams. For question 2, it asked us to calculate the mass of carbon dioxide produced in the reaction of 3.2 grams of methane with excess oxygen. So the first thing you have to do again is check that that equation is balanced. Okay, the way you can do this is underneath the arrow here, you can write down the elements that are present. So we've got CHO there, we've got carbon, hydrogen and oxygen. And on this side of our CHO, we'll write down what we have on our reaction side, and on the product side, we'll write down here how many we have on our products. So on the reaction side, we've got 1 carbon, hydrogens we have 4, and oxygen 2 times 2, so we've got 4 oxygens. On our product side, we've got 1 carbon. For hydrogens, we have 2 times 2, which is 4, and for oxygen, we have 2 here and 2 over here, so again that's 4, so it is balanced, so we can say step 1 is done, our equation's balanced. Next thing to do is write down which of these compounds you're actually interested in. So calculate the mass of carbon dioxide produced in the reaction of 3.2 grams of methane. Okay, so you can cross these two out, we're not interested in those, and rewrite. Our second step is looking at our mole ratio. We can see here that it is a 1 mole to 1 mole ratio. For our third step, we have to work out the number of moles that we actually have. Number of moles equals mass divided by gram formula mass. The mass of methane given to us in the question is 3.2 grams. And the gram formula mass we can calculate ourselves. We have 1 carbon, 1 times 12, and we have 4 hydrogens, which is 4 times 1. We then bring that number up, so we've got 3.2 divided by 16, and that will give you 0.2 mole. We then bring our newly calculated number of moles up and we complete our mole ratio. If we had a 1-to-1 ratio before, it means that these numbers are going to be the same on both sides. Okay, or you could do 0.2 times 1 divided by 1, and you will find that this is also a 0.2 moles. And now on to our fifth and final step, which is to calculate the mass of carbon dioxide like the question asked us. Mass equals number of moles times a gram formula mass. Our number of moles we've calculated to be 0.2, and our gram formula mass we can work out. We have 1 carbon and we have 2 oxygens. Add that up, we get 44. 0.2 times 44 will give you 8.8 grams. So the mass of carbon dioxide produced in the reaction of 3.2 grams of methane with excess oxygen is 8.8 grams. Moving on to question 3. Calculate the mass of sodium oxide produced in the reaction of 2.3 grams of sodium with excess oxygen. So first step, let's have a look, I'll write it down here so we've got some more room, at balancing our equation. We have 4 sodiums on our reaction side, and we have 2 times 2 sodiums on our product side. However, when we look at our oxygens, here we have 2 times 2, so we have 4 oxygens, and on this side we only have 2 oxygens. So what you have to do is this entire side has to be multiplied by 2. So 2 times 2, so we would change this 2 here to a 4. That is then going to make us have 8 sodiums on this side, and that 2 will change therefore to 4 oxygens for us. Okay, so now our oxygens are balanced, and what we have to then do over here is times this one by 2 to make it 8. So over here, instead of 4 sodiums, we have 8 sodiums, and if we just check that, 8 sodium, 4 times 2, 8 sodium, 2 times 2, 4 oxygen, 4 times 4 oxygen. Okay, so now that we've balanced it, and I'm just going to write it out again underneath so it's a bit neater for you there. And then if we read the question, calculate the mass of sodium oxide produced in the reaction of 2.3 grams of sodium with excess oxygen. So I would cross out the oxygen and ignore that there. Okay, so we've done step 1, we've got our equation balanced. We're moving on to step 2, which is our mole ratio. Now you could quite happily leave that as an 8 mole to 4 mole ratio, or you could at this stage divide down and make it a 2 to 1 mole ratio. It doesn't matter which of these ratios you work with going forward, you should still get the same answer. Step 3, calculating the number of moles that we actually have. We are given 2.3 grams of sodium in the question, so our mass is 2.3. And remember, when we're asking you to work out the gram formula mass here, we're only interested in the chemical formula, so the sodium, which is 23. We do not times this by 8. The 8 here has to do with the number of moles. So as soon as this comes down, it's almost like you ignore it. You do not include the big number when you're calculating your gram formula mass. So 2.3 divided by 23 will give you an answer of 0.1 mole. You can then bring that up and use that in step 4. So we have 0.1 moles. Now before we had a 2 to 1 ratio. It's the same here. So what you could do is 0.1 times by 1 divided by 2, and it will give you a 0.05 moles. So all you've done is you've halved the number of moles that you started with. And finally, on to our last step to calculate the mass of sodium oxide produced. Mass equals number of moles times the gram formula mass. Our number of moles we calculated to be 0.05 moles. And our gram formula mass we can work out. Sodium oxide, Ne2O. 2 times 23 gives you 46. And 1 times 16 gives you 16. Add that all up, you'll get 62. 0.05 times 62 will give you 3.1 grams, which is your final answer there. So the mass of sodium oxide produced in the reaction of 2.3 grams of sodium with excess oxygen is 3.1 grams. Moving on now to question 4. Calculate the mass of hydrogen required to react with 56 grams of nitrogen. 2 nitrogens, 2 nitrogens, 6 hydrogens, 6 hydrogens. It's balanced. We're calculating the mass of hydrogen required to react with nitrogen. So this time you're ignoring your products completely. So when you rewrite that, there's 2 ways you could rewrite it. You could just do nitrogen plus hydrogen. Or you might want to rewrite it like this, where R/W stands for reacts with. It is entirely up to you. Okay, moving on then to our second step, our mole ratio. We have 1, no big numbers in front, so we've got 1 mole of nitrogen and 3 moles of hydrogen. Third step is calculated the exact same way as usually. Number of moles equals mass divided by the gram formula mass. The mass of nitrogen we are given in the question, it's 56 grams, and we have to calculate our gram formula mass. (56) divided by 28 will give you an answer of 2 moles. So in an ideal world, we would get 1 mole of nitrogen and it would react with 3 moles of hydrogen. In actuality, what we have is 2 moles of nitrogen and it will react with 6 moles of hydrogen. Okay, 2 times 3 divided by 1. using our new number of moles that we've just calculated, we can work out the mass of hydrogen that we would be required to use. Number of moles is 6 and our gram formula mass is 2. 2 times 1 gives us 2. So our final answer here is 12 grams. We would need to have 12 grams of hydrogen to react fully with 56 grams of nitrogen. Question 5. Calculate the mass of oxygen required to react with 2.7 grams of aluminium. First steps first, check that your equation is balanced. 4 aluminiums, 2 times 2, 4 aluminiums. 3 times 2, 6 oxygens, 2 times 3, 6 oxygens. It is balanced. Reading through the question, we can see which species we are interested in. Calculate the mass of oxygen required to react with 2.7 grams of aluminium. So again, we are ignoring our products. We have 4 moles here of aluminium reacting with 3 moles of oxygen. Step 3, let's calculate the number of moles that we actually have. Number of moles equals mass divided by gram formula mass. We have 2.7 grams of aluminium. If we work out the gram formula mass of aluminium, remember we ignore the 4. That is to do with our number of moles. So we just work out what the relative atomic mass is for aluminium, and it is 27. 2.7 divided by 27 will give you a number of moles as 0.1 moles. Bringing that back up for step 4. So in an ideal world we would have 4 moles of aluminium reacting with 3 moles of oxygen. What we actually have is 0.1 moles of aluminium. So to work out our number of moles of oxygen, we would do 0.1 times by 3 divided by 4. And our answer would be 0.075. On to our final step to calculate the mass of oxygen that we have. Mass is number of moles times gram formula mass. Our number of moles we've just calculated, so we can bring it down. 0.075 moles times our gram formula mass of oxygen. It's diatomic, remember. 2 times 16, which is 32. 0.075 times 32 will give you an answer of 2.4 grams. So the mass of oxygen required to react with 2.7 grams of aluminium is 2.4 grams. And on to our final question for today. Calculate the mass of copper produced in the reaction of 9.8 grams of magnesium with excess copper to sulfate. Remember, if it says excess, we're not interested in it. But first, let's see if it's balanced. 1 magnesium, 1 magnesium. 1 copper, 1 copper. And for this, you could just look at sulfate as a group. SO4, one of those on our reactant side, one on our product side. So yes, it is balanced. Now, be careful when you're rewriting this one. Calculate the mass of copper produced, copper just on its own, and the reaction of 9.8 grams of magnesium with excess copper sulfate. If it's excess, you don't know how much of it you've got, so you can't use it in the calculation, and we're not interested in magnesium sulfate. So rewriting. And for step 2, we have 1 mole giving 1 mole. Back to a nice easy 1:1 mole ratio. For step 3, to work out the number of moles we actually have, mass divided by gram formula mass. The mass of magnesium is given to you in the question as 9.8 grams. If you look in your data book for the relative atomic mass of magnesium, you'll find it's 24.5. 9.8 divided by 24.5 will give you an answer of 0.4 moles. Bringing that back up to our mole ratio. Before we had a 1-to-1 ratio. In actuality, we have a 0.4 mole to 0.4 mole ratio. And moving on to our fifth and final step. To calculate the mass of copper produced, we do the number of moles times the gram formula mass. The number of moles of copper we have is 0.4, and our gram formula mass is taken straight from the relative atomic mass from our data book for copper, which is 63.5. 0.4 times 63.5 will give you a final answer of 25.4 grams. So the mass of copper produced in the reaction of 9.8 grams of magnesium with excess copper 2 sulfate is 25.4 grams of copper.